Welcome back. Today, we're tackling something pretty mind-blowing: superposition in the quantum tech world. We'll explore a surprising parallel. Okay, in quantum mechanics, there's this core principle called superposition. It just means a tiny particle, like an electron, can actually exist in multiple states or places at the exact same time. It's not just in one spot or another. It's in a combination of all possible spots at once. This is represented by a mathematical equation, a wave function, that describes all these possibilities combined. This state of multiple possibilities is what allows quantum computers to perform incredibly powerful calculations, exploring many paths simultaneously. However, the moment you try to measure or observe the particle, this superposition collapses. The particle is forced to choose one single, definite state. You can no longer see the combination of possibilities, only the final outcome. Furthermore, just as quantum superposition is a delicate state, easily disturbed by its environment, a process called decoherence to profound meaning, and can be lost if not approached with the right mindset. If one reads it with a closed heart or a predetermined agenda, the rich superposition of meanings can collapse into a flat, one-dimensional interpretation. The environment of the reader, their sincerity, their openness, their knowledge is crucial for the text to reveal its deeper dimensions. A superficial or hostile reading can cause the decoherence of its spiritual and ethical layers, leaving only the shell of the words. Have you ever heard that a tiny particle, like an electron, can be in multiple places at the exact same time? It sounds like something straight out of science fiction, right? Well, this isn't a movie plot. It's a fundamental principle of the quantum world called superposition. Today, we're diving deep into what superposition really is, how it works, and why it's changing the future of technology. So, what does it actually mean for a particle to be in a superposition? It's a common misconception that the particle is literally in all possible states simultaneously, like a ghost scattered across a room. The reality is a bit more mathematical, but just as fascinating. Superposition describes a state where a particle exists as a combination of all its possible outcomes. Think of it like a spinning coin. Before it lands, it's not heads, and it's not tails. It's in a state that contains the potential for both. Only when we measure it, or when the coin lands, does it choose one specific outcome. In the quantum realm, this is described by something called a wave function. This wave function is a mathematical recipe that lists all the possible states the particle could be in, like its position, energy, or spin. For each of these possibilities, there's a corresponding number called a probability amplitude. Now, these aren't just simple probabilities, like you'd find in a coin toss. They are complex numbers, and when you square their magnitude, you get the actual probability of finding the particle in that specific state upon measurement. So, before measurement, the particle is in this delicate, probabilistic dance of all potential realities. The act of measuring forces it to pick one, a process known as the collapse of the wave function. This idea is so counterintuitive that it has puzzled scientists for over a century. One of the most famous illustrations of this is the double-slit experiment. Imagine firing single particles, one by one, at a barrier with two tiny slits. Classically, you'd expect to see two distinct lines of impacts on a screen behind the barrier, corresponding to the two slits. But that's not what happens. Instead, an interference pattern emerges, a series of bright and dark bands, just like you'd see if waves were passing through the slits and interfering with each other. This is incredible because it means each individual particle, traveling alone, somehow goes through both slits at the same time, interferes with itself, and then lands on the screen in a specific spot dictated by this wave-like behavior. This experiment provides solid, repeatable proof that particles exist in a superposition of paths until they are detected. Now, why does any of this matter outside of a physics lab? The answer lies in the revolutionary field of quantum computing. Classical computers, like the one you're probably watching this on, store information in bits, which can be either a 0 or a 1. They are like light switches, either on or off. Quantum computers, on the other hand, use quantum bits, or qubits, thanks to superposition. A qubit can be a 0, a 1, or a combination of both at the same time. This ability to exist in multiple states at once allows quantum computers to process a staggering amount of information simultaneously. Imagine trying to find a specific name in a massive phone book. A classical computer would have to check each entry one by one. A quantum computer, by leveraging superposition, could essentially check all the entries at once. This parallel processing power gives quantum computers the potential to solve certain types of complex problems exponentially faster than even the most powerful supercomputers we have today. We're talking about problems in drug discovery, materials science, financial modeling, and breaking complex encryption codes that are currently unbreakable. Superposition is also the backbone of other emerging quantum technologies. Take quantum cryptography. For example, it uses the principles of quantum mechanics to create provably secure communication channels. If an eavesdropper tries to intercept a message encoded in a quantum state, the very act of measuring it disturbs the superposition, immediately alerting the sender and receiver that the communication has been compromised. This creates a level of security that is physically impossible to achieve with classical methods. Another application is in ultra-precise sensing. Atomic clocks, the most accurate timekeeping devices ever created, rely on the superposition of energy levels in atoms. By measuring the frequency of radiation needed to switch an atom between two states, we can define time with incredible precision. This technology is crucial for GPS, financial networks, and scientific research. Quantum sensors built on superposition principles promise even greater sensitivity, allowing us to detect tiny gravitational fields or magnetic signals from the human brain. However, harnessing the power of superposition is incredibly challenging. The main enemy is a phenomenon called decoherence. A quantum superposition is extremely fragile. It needs to be perfectly isolated from its environment. Any interaction with the outside world, a stray photon, a vibration, a change in temperature can cause the superposition to collapse. This is decoherence. The quantum system loses its quantumness and starts behaving like a classical object. This is why quantum computers are so difficult to build. They require extreme cold, near-perfect vacuums, and sophisticated shielding to protect the qubits from environmental noise and maintain their coherent superposition long enough to perform calculations. So, to wrap it all up, quantum superposition isn't just a quirky, abstract idea. It's a verified and fundamental aspect of how our universe works at the smallest scales. It's not that we just don't know the particle state. The particle genuinely exists in a combination of possibilities until we look. This defiance of our everyday logic is what makes quantum mechanics so bizarre but also so powerful. From revolutionizing computing to securing our data and helping us explore the universe with unprecedented accuracy, the ghostly dance of superposition is paving the way for a future we are only just beginning to imagine. It's a reminder that reality is often far stranger and more wonderful than we can perceive. Thanks so much for joining me on this journey into the quantum world. Hit that like button and subscribe for more deep dives into the mysteries of science. Let me know in the comments what quantum topic you'd like to explore next. Until then, stay curious. Ever feel like you're in two places at once? Well, in the bizarre world of quantum mechanics, tiny particles actually can be. This mind-bending concept is called superposition, and it's one of the cornerstones of the quantum universe. So, what exactly is it? Let's start with what it's not. It's not just that we don't know where a particle is. It's that the particle genuinely exists in a combination of all its possible states simultaneously. Imagine a coin spinning in the air. Before it lands, it's not heads or tails, it's a mix of both. That's superposition for a quantum particle, but way weirder. It's described by math using something called probability amplitudes, which are complex numbers that tell us the likelihood of finding the particle in a specific state once we decide to look. The moment we measure it, or it interacts with its environment, this fuzzy state of possibilities collapses into a single, definite reality. It's like the spinning coin finally landing. This process is called decoherence, and it's the reason we don't see superposition in our everyday lives. Big objects are constantly interacting with everything around them, forcing them into a single state instantly. But how do we know this is real and not just some wild theory? The classic double-slit experiment is the smoking gun. When you fire individual particles, like electrons, at a screen with two slits, you'd expect to see two bands on the detector behind it. Right? But that's not what happens. Instead, we see an interference pattern. just like waves would create. This proves each particle went through both slits at the same time, interfered with itself, and then landed in one spot. It was in a superposition of paths. This isn't just a quirky feature of the universe, it's incredibly useful. It's the superpower behind quantum computing. A classical computer bit is either a 0 or a 1. But a quantum bit, or qubit, thanks to superposition, can be a 0, a 1, or both at the same time. This allows quantum computers to process a massive amount of information simultaneously. For certain types of problems, like developing new materials or breaking complex codes, this gives them an exponential speed advantage over even the most powerful supercomputers we have today. The applications don't stop there. Superposition is key to quantum cryptography, which promises unhackable communication channels. If a spy tries to intercept a message encoded in quantum states, the very act of observing it collapses. The superposition altering the message and immediately revealing the eavesdropper. It's also revolutionizing sensor technology. Atomic clocks, the most accurate timekeeping devices in existence, use the principles of superposition to achieve mind-boggling precision, which is crucial for things like GPS and financial networks. So, from the double-slit experiment to the promise of quantum computers, superposition is a fundamental, verifiable, and actively used aspect of reality. It challenges our classical intuition and forces us to accept that at the smallest scales, the universe operates by a completely different set of rules. It's a world of probabilities and possibilities, where particles live in a ghostly blend of states until the moment of observation. Understanding superposition is the first step into the strange and wonderful realm of quantum mechanics. So, where is this all heading? The potential is enormous. Superposition isn't just for computing. It's at the heart of quantum sensing, allowing for devices that can measure magnetic fields with incredible precision, which could revolutionize medical imaging. It's also crucial for quantum communication, enabling a new era of ultra-secure networks that are theoretically The road ahead is long, and controlling decoherence is the main mountain scientists are climbing. But every day, we're getting better at creating and maintaining these delicate quantum states. The journey into the quantum realm has just begun, and the ability of particles to be in multiple places at once is our ticket to a future we can barely imagine. It's a world built on possibilities, and we're just learning how to harness them. Hey everyone, welcome back to the channel. Today, we're diving into a concept that sounds like it's straight out of science fiction, but is actually a fundamental principle of our universe. Superposition. You might have heard it mentioned in relation to quantum mechanics, and we'll definitely get to that, but the idea is much broader and surprisingly intuitive. So, what exactly is it? At its core, superposition is a simple but powerful idea from physics and math. It states that for certain systems, the total effect is just the sum of its individual parts. Imagine you're at a pond. If you throw 2 pebbles into the water, the ripples from each one will spread out. Where those ripples meet, they don't just cancel each other out or bounce off. Instead, they combine. The height of the new combined wave at any point is simply the sum of the heights of the individual waves. If a peak meets a peak, you get a bigger peak. If a peak meets a trough, they might cancel each other out. That's superposition in action, a principle that originated from classical wave theory. This simple idea of adding things up applies to all sorts of waves, not just water. Sound waves, light waves, even radio waves, all follow this principle. Think about listening to an orchestra. You can hear the violins, the cellos, and the trumpets all at the same time. Your ear and brain are able to process this complex sound because the sound waves from each instrument are superposed or layered on top of each other as they travel to you. You're not hearing a jumbled mess. You're hearing a rich, combined sound. The same goes for Wi-Fi signals. Multiple devices in your home can send and receive data simultaneously because their signals, which are just radio waves, can coexist and be decoded separately. It's all thanks to superposition. Now, let's venture into the weird and wonderful world of quantum mechanics, where superposition gets really famous. Here, it's not about waves in a pond, but about the fundamental properties of subatomic particles like electrons. According to quantum mechanics, a particle doesn't have a single, definite state until it's measured. Instead, it exists in a superposition of all its possible states at once. Think of a spinning coin. While it's in the air, it's not heads and it's not tails. You could say it's in a combination of both. It's only when you catch it and look, when you make a measurement, that it settles into one definite state, either heads or tails. A quantum particle is kind of like that, but even stranger. An electron, for instance, can have a property called spin, which can be up or down. Before we measure it, the electron isn't just one or the other. It's in a superposition of both spin up and spin down simultaneously. It's a mind-bending idea because it goes against our everyday experience, where things are either here or there, on or off. In the quantum realm, it can be both. This is famously illustrated by Schrödinger's cat, a thought experiment you've probably heard of. You imagine a cat in a sealed box with a radioactive atom. If the atom decays, it triggers a mechanism that releases poison and, well, you know, the atom's decay is a quantum event. So, until we open the box and observe the system, the atom is in a superposition of both decayed and not decayed. And if the atom's state is tied to the cat's fate, then the cat, in a sense, is also in a superposition of being both alive and dead at the same time. Of course, this is just a thought experiment to highlight the strangeness of quantum superposition when applied to large-scale objects. We don't actually see cats that are both alive and dead. The act of measurement, or observation, is what forces the system to choose a single outcome. This collapse from a superposition of states into a single state is one of the biggest mysteries in quantum physics. But superposition isn't just a weird theoretical quirk. It's the driving force behind technologies that are set to revolutionize our world. Let's start with a field that's a bit more down-to-earth. Electronics. Engineers use something called the superposition theorem all the time. Imagine a complex circuit board, like the one inside your phone, with multiple power sources maybe, a battery, and a charging cable. Analyzing how all the currents and voltages flow at once can be incredibly difficult. The superposition theorem simplifies this. It allows engineers to calculate the effect of each power source, one at a time, by turning all the others off. Then, they simply add up the individual results to find the total effect. It's a classic application of the sum of its parts principle, making circuit design and analysis manageable. And now for the big one. Quantum computing. Superposition isn't just a feature of quantum computers. It's one of the core pillars that gives them their incredible power. A classical computer bit is either a 0 or a 1. That's it. But a quantum bit, or a qubit, can be a 0, a 1, or a superposition of both 0 and 1 at the same time. What does this mean? It means a quantum computer can explore a huge number of possibilities simultaneously. If you have two classical bits, you can represent one of four possible combinations. Oh, 0, 1, 10 or 11, but you can only work with one of these combinations at a time. With two qubits, thanks to superposition, you can represent all four of those combinations at once. As you add more qubits, the number of states you can represent simultaneously grows exponentially. With just 300 qubits, a quantum computer could represent more states than there are atoms in the entire observable universe. This allows them to perform massive parallel calculations, tackling problems in fields like drug discovery, materials science, and cryptography that would take the fastest classical supercomputers billions of years to solve. Superposition is what gives quantum computing its quantum leap in processing power. But the influence of superposition doesn't stop there. It even reaches into the ground beneath our feet, in the field of geology. Here, we have the law of superposition. It's a fundamental principle for understanding Earth's history. It states that in a sequence of undisturbed sedimentary rock layers, the oldest layers are at the bottom, and the youngest layers are at the top. Think of it like a stack of newspapers. You put today's paper on top of yesterday's, and yesterday's on top of the one from the day before. If you want to find the oldest news, you dig down to the bottom of the pile. Geologists use this law to determine the relative ages of fossils and rock formations, piecing together the timeline of our planet's past. It's a different context, but it shares the name and the core idea of things being layered, or superposed on top of one another. So, from the ripples in a pond to the very fabric of reality, from designing the electronics in your pocket to building the revolutionary computers of tomorrow. And even to reading the history of our planet in stone, the principle of superposition is everywhere. It's a beautiful example of how a single, elegant idea can manifest in so many different ways, connecting seemingly unrelated fields of science and technology. It shows us that sometimes the most complex systems can be understood by breaking them down and then adding up the parts. And in the quantum world, it reveals a reality that is far more flexible and full of potential than we ever could have imagined. Thanks for watching! If you enjoyed this deep dive into the quantum world, don't forget to like, subscribe, and hit that notification bell for more videos exploring the frontiers of science. See you next time.